talk about soil today. It's a really important part of the garden. We are going to do something called a soil shake test. And what you need for this is a jar with a lid, some water, some dish soap, and something to dig with. I really recommend these things. These are called garden knives or hori-horis. And it's my favorite tool in the garden. I'm just saying, if you want to get one, these are awesome. So what is soil? Soil is made up of solid material. It's made up of organic matter. It's made up of spaces. There's water in it. There's bugs. And it covers the surface of the earth. It's really important. It affects our life every day, and we don't even know it. So I have this pet peeve about people calling soil dirt. Dirt has this connotation of being something dead, something we get under our nails, or something you have to clean off your clothes. But soil is something positive. It's something we're going to use a lot of in the garden. So for this soil shake test, we are going to fill our glass jar half full with soil. We need to dig down about 6 inches to take our soil sample. I'm going to go ahead and fill the jar about halfway with soil. Try not to get any big rocks in it, if you can help that. Is that about half? It's about half. Then you're going to put about a teaspoon of dishwashing liquid in there. And then you're going to add the water. You want to nearly fill it with water. You may be wondering why we add the dishwashing liquid. That's because it's a surfactant. So what it does is it will bind on to the individual particles in the soil and help to separate them so that they can form really clear, distinct layers. So now you want to shake it up, and you want to shake it for about 2 minutes. After you've shaken it for the full 2 minutes, you're going to find a place where you won't touch it for about a day, and you're going to just let it sit there for 24 hours, and then you can go ahead and study the layers. Soil is made up of sand, silt, clay, water, air, spaces, organic matter, and organisms. Did I get it all? Yeah, I think I did. Okay, so if you were to just pick up some soil in your hands and go ahead and feel it, if it felt gritty at all, that's because it has sand in it. And sand is really important in your garden because it gives your soil porosity or pore spaces that are large and volume. It makes the soil loose and have spaces for water, air, nutrients, and bugs to move through it. If you have too much sand, water is going to run right through it. You're going to be watering all the time. When that water moves through your soil, it also picks up your nutrients and takes those away out of the region where the roots can get it. So you need a good balance of sand in your soil. If you have too little sand, the drainage of your soil will be very poor. If when you feel your soil, it feels kind of floury, that's the silt in the soil, and that's able to hold on to water and nutrients a little bit better than sand. The pore spaces between the silt particles are smaller, so water doesn't flow nearly as quickly. Too much silt, though, can make your soil kind of mucky, especially if it rains a lot. And just imagine the soil at the bottom of a pond, that is kind of gelatinous, mucky soil down there. It's where frogs will hibernate in the winter. Silt also is sparkly, so you If you look closely, you might see it sparkling a little bit. If when you feel your soil, it feels very, especially if it's wet, if it feels very slimy and sticky, that's clay in your soil. And what clay does in your soil is it gives your soil strength. It holds on to water really well, and also it holds on to nutrients and makes nutrients available for the roots of your plant to take in. Too much clay in your soil and it will become waterlogged, and when it dries up, it'll be almost impenetrable, like you will not be able to dig through it. Too little clay and your soil will not be able to hold on to the nutrients that your soil needs. So it's really important to have sand, silt, and clay all together in your soil. There's also air in the soil, and quite a bit of the soil is made of air, around 40%. It is important to allow plants, roots, and animals to move through the spaces in your soil. So you need these air spaces. And when you are first building your garden, you're going to want to till it, or what's called double digging, and that's basically you're just breaking up all the compacted soil that you've had over the years in the location where you want to put your garden. After that first year, you really don't need to do the heavy tilling. What happens is the bugs that move through your soil and the water over time, they make these air spaces and build up this community underneath the ground, and you don't need to do any heavy tilling, just usually on the top. A little bit of raking on the top is sufficient. There's water in your soil. Obviously, we know we have to water plants, and water clings to soil particles, and that gets taken up by the plant roots. You also have organic matter, which is matter that has come from recently living organisms. So this includes things like compost and manure. If I were to look at my soil, I can see a lot of organic material. There's sticks in here, there's plant roots from the last season, leaves, and then a whole bunch of it is just really small that I can't just see. What else is in the soil? Organisms. There's bacteria, fungus, worms, insects. I mean, as I look through here right now, I see millipede, like little tiny flies. All this stuff is in your soil and makes it what it is.
Now back to our soil shape test.
We have here 2 soil samples from 2 different areas of my yard. One is my old garden, and the one on the left is the new area I will be gardening. So you can see just by generally looking at these that layers have formed. These have been sitting for well over 24 hours. You'll see here the first layer is the biggest in this sample, and that's the sand. We've talked about how sand is made up of the largest grain size, and so it is the heaviest, and it will fall down out of the water first. From this line to this line here, in between there is all the silt layer. Silt's grain size is quite a bit smaller than sand, and so it takes a little bit longer for it to settle out of the water. And the last layer right in between this line and the top line, it's a very thin, that's the clay layer, and clay is super small grain size, and so it takes a long time for it to settle out of the water, and that's why we wait 24 hours. You can see that this soil sample is dominated by sand. Over here in this other sample, the sand goes from the bottom up to this line, and the silt is from this line to this line, so that's all the silt. And then from this line up to the top line is another small layer of clay. Similar amount of clay, different amount of sand, and different amount of silt. All this up here above the clay layer, that's just water. And then floating on the top is organic matter. And you can see a little bit better in this sample. You'll see needles, bark, pieces of grass, moss, all floating on the top. After a while, some of it will fall down and settle on top of the clay layer, and you can see some of that right here. So what we get out of this is if you want a loamy soil, You want something with about equal amounts sand and silt and just a little bit of clay. You are really reaching for this type of soil over here, not this. This one is way too sandy. Now we got to measure the height of each layer. But before we do that, we need to measure the height of all the layers together. So up and from the bottom all the way up to the very top of the clay layer. So from down here to up to that top line there. You're going to want to use a ruler that has centimeters on it. And we're going to be actually measuring in millimeters. So those are all those tick marks in between the numbers. So first you measure the total height of all the layers, and then you will break it down into measuring the height of the sand layer, the height of the silt layer, and then the height of the clay layer. Alright, here we are, we're going to do some math. So we have to get the percentage of each type of material, the clay, the sand, and the silt. So to get the percentage, we use those numbers that we got with our ruler, the height of each layer. So I measured the height of my sand layer was 40 millimeters high. The silt layer was only 9 millimeters high, and the clay layer was 3 millimeters high. And when you add those all together, the height of all the layers together was 52 millimeters. So when you want to get percentage of something, you just take the height of the layer and you divide it by the total height of all three layers. So for sand, the height was 40, and then you divide that by 52, which is the total. That will come out to 0.77, and then to get your percentage, you just times it by 100 and you get 77%. And I just followed the same thing with silt. 9 millimeters was the height of the silt. The total height of all three layers was 52 millimeters, so I divided by that. That equaled 0.17, multiply it by 100, and I got 17%. And the last one was clay, and I got 6%. So, our soil sample was made up of 77% sand, 17% silt, and 6% clay. Now we're going to take a look at a ternary diagram and figure out what these percentages mean as far as soil texture goes. We're going to use this here ternary diagram to figure out what type of soil we have. And you'll notice that it is a triangle shape, so it may seem a little confusing right now, but it'll make sense in a minute. This axis here is going to be your percentage of clay. This axis right here is your percentage silt. And then this bottom axis here is your percentage sand. Really, really good quality soil is loam soil. And loam soil is about 50-50 sand and silt and a little bit of clay. If you have really sandy soil, your soil is going to drain really quickly. Nutrients will be leached out of it. So those are some of the problems with sandy soil. If you have very clay soil, what happens is there's a lot of standing water usually, so roots can rot, vegetables can rot. And then really high silty soil is kind of light in the wind, and so it can blow away if there was a windstorm. So there's some drawbacks of having strictly clay, silt, or sand soils. You're really hoping for things more in the center of the diagram. We are going to go ahead and chart the soil that we sampled here in this video. So if you remember, we had 77% sand in our sample. So you're going to go and take a pen and you're going to mark a line right where 77 is on this sand axis. Silt, we had 17%, so you come along here and mark a line at 17. And then clay, we had 6%, and that's way down here, so 6%. And what you'll do is you'll draw lines and you'll find the point where they intersect. And ours intersects right here. So you can see that our soil is loamy sand. At least the word loamy is in there. That's something, but it's still very, very sandy. So this is exactly why I moved my garden, is because the soil was so sandy and I would have to water all the time, and I'd have to add a lot of compost and a lot of fertilizer because all the nutrients would just get leached right through it with the rain. So that's how you use a ternary diagram. If you find that your results are in any of the vertices or the corners, you might want to consider a different space in your garden. But if it's anywhere around the middle, just adding compost about 1 inch per year can really improve your soil. And if you're lucky enough to have soil right here in the middle, then you're set. We learned a lot about soil today, and we learned that it's not just something dead or something that gets under your fingernails. It's something alive. It's something super important to growing a garden. And you learned how to do a soil shape test and how to find layers of sand, silt, and clay in your soil and what that means for the texture of your soil, which ultimately tells you how to water, how much fertilizer and compost add, and so on. So I hope this was helpful, and go out and plant something. Pedologist is the soil scientist. And it's kind of cool because you can break it down into its root words in Greek. And pedon means soil, and logos means to study. So if you put those together, pedologist means someone who studies soil.